The conference is great. It's been really interesting. The caliber of the participants here are really high. It was my first time here at the conference, so I didn't know what to expect. But everyone here seems to have at least picked up a soldering iron. Some people have actually built some very impressive things, and I've learned a lot too. Actually, it's been good going to the sessions and hear other people's ideas and inputs on different Linux-related things. There's one guy who's also building an FPGA plus ARM-based computer, and it was really interesting to hear his talk. So I mean, that's very close to the kinds of things that I do. And then just got to meet the OpenStack guys who are doing the cloud computing environments, and that was like an eye-opener to see that it's actually available. And then all the model rocketry stuff and just talking to people and meeting people has been really great. In my past life, like before when I was in grad school and stuff, there's some work I did on the Xbox that people know me well for, but since then I've done a lot of other things. I went through a phase of doing chip design, so I was designing Wi-Fi chipsets, and then I went to a company doing nanophotonic integrated circuits where I actually had designed some of the first high-speed modulators on die with silicon. Silicon drivers, and then after that I decided to go more into consumer electronics. I did a company called Chumby, where we wanted to sort of bring the cloud internet to all kinds of consumers all over the place, and make it very approachable and affordable. And so we're embedding Linux and alarm clocks and picture frames and TVs, all that sort of stuff. And then since then I've been kind of on my own. Last year I've been sort of independent. Living in Singapore, kind of trying to look around for new ideas and doing things that are interesting and good and fun. Singapore is kind of got everything a geek really needs. I mean, they have 100 megabit fiber connections to the home for a very reasonable price. I have 2 of them, and the food is quite cheap. Rent is very reasonable, particularly if you can get into public housing. And you don't have to have a car. Medical care is very reasonable. So a lot of things that you would normally have to worry about if you're trying to do like a startup or be independent are taken care of by the infrastructure there. So it's been quite good actually. Can really focus on innovating and trying to do something new. When I was in college, it was sort of a coin toss whether I was going to go to biology or computers, and so I've always had this lingering interest to learn more about biology. So recently, I through the good graces of the local institute in Singapore, Genome Institute of Singapore, I did an internship with the infectious diseases group, and there I was doing some research on sort of the regulatory mechanisms of phage versus E. coli, and it was really sort of coming from like a hardware background. You sort of know that you don't really know what you're talking about until you've actually done it, right? You have to really get your hands dirty or get your hands wet, as it may be, in the biology lab. And so I'd read a lot about the theory of how informatics works and sort of the theory of how you might do a transformation or how you might do a knock-in clone or a knockout clone. And it was really interesting to just get in there, try to design some experiments, see them fail, see how they work, see how unexpected results can be very interesting. So it was a really good experience. Internship is now finished, but I hope someday to be able to return to that lab or some other lab and do a little more work. I have some ideas for things that I'd like to try or explore further. There's two observations. Number one is that it feels to me that biology lab equipment is kind of caught in the Stone Ages, like the 80s or 90s or something like that, right? So to do a culture growth, right, you want to hit a particular OD. You have to go back and check every hour, 2 hours, or something like this when you get close. And so we do these things we wouldn't be able to eat lunch. We'd have to sit there and eat outside the lab, get all suited up, check, come back, finish our lunch or something like that. It seems silly that the thing is not connected to the internet and doesn't just send you a tweet when it's actually done with growing to a particular level. And all the equipment is there in the lab, and all the pieces, they just need to kind of be merged together into a piece of equipment. And when you look at what is behind it, it's a shaker, it's a heater, and it's a photodiode with a photo emitter. These pieces are not rocket science. It's been hard getting them all together in one box. So I think that there's a lot of room, low-hanging fruit, in sort of the basic equipment level that can perhaps help science automate more and people be more productive. Although I fully understand that biologists have their protocols and want to stick with it, it's hard to sell them on new things. But I think there's room there. What is behind it, it's a shaker, it's a heater, and it's a photodiode with a photo emitter. These pieces are not rocket science. It's been hard getting them all together in one box. So I think that there's a lot of room, low-hanging fruit and sort of just the basic equipment level that can perhaps help science automate more and people be more productive. Although I fully understand that like biologists have their protocols and they want to stick with it, it's hard to sell them on new things. But I think there's room there. And the other thing is what was the other thing? The first one was the equipment. Oh, the other thing is that I find it's interesting because biologists they're essentially reverse engineers. They have a very complex system, and they have to perform these experiments on these black boxes and trying to figure out like how it works or how it breaks, how to change it through this very empirical observations. Computer scientists tend to be the opposite. They like to design from the bottom up. I do both. I do design and reverse engineering. And both processes get you into these sort of mental traps of how you think about the world. Like when you reverse engineer, you get into some particular dogmas about how things must work because you've done a lot of work. And so the rejection of the biology community of like short RNA sequences when they first came out as being ever functional or having any role sort of is a symptom of like the dogma that can happen in biology. You really have to sort of work hard to overcome certain thinkings. But you know, if you come from the computer science background and you say, okay, well, you know, what can these short RNA sequences do? Well, they can template onto mRNAs and prevent transcription, whatever it is. That makes sense, right? I mean, that seems to be a perfectly possible thing. And so I think maybe applying more of the other kind of thinking to look for other potential areas could be interesting. So, I mean, that's a very vague thought, but I feel like there could be some contribution there. I think it's more just getting the idea out there that more people from engineering backgrounds should get into science. It's interesting, it's cool, it's definitely like really fascinating and very complex systems. There's a lot to really get into, but a lot of people from my background would think it's intimidating or scary to learn about a whole new system of biology. But actually, it's another system, it has a lot of rules. It's like learning a new programming language in some ways. I mean, if you stay out of the lab, it's like learning a new programming language. I would really like to be able to make a contribution. I don't know if I can, right? That's yet to be seen. I'm still kind of looking for the right angle or direction in that area. I do look forward to generally the industry getting more automated and having more services. The biology today, DIY bio today, is a bit like step one, you know, get FR4 with copper on it and then etch traces and then drill the holes and then you can build your circuit, right? It's not like build your circuit. You have to do all these little things before you can actually do the experiment you actually cared about, right? I think hardware today is really taking off because you can just spin out a circuit board to somebody with a design. It's all just bits and it comes back as atoms and you're like, yay, I can put my components on and do my thing. Biology is getting to the point where like you can start ordering plasmids in, you can get, you know, competent bacteria, and you can get all the bits and pieces that you need sort of outsourced, so you can actually just say, I want to do this particular experiment, and you can put them together in a single step and then actually get to the result you're looking for. I think more of that will help more people participate. If we can get either like sequencing or programming sort of into the home environment so it's really cheap and basically you don't have to think about it. Like if your child has a sniffle, you just put some snot in a little thing and it tells you what your kid has. Or if you don't know if your fish is like actually the fish you bought, or you want to know where the grapes for your wine came from, you want to know how your you know, gut is doing, you can sample your poop and put it in there, right, and see how your bacteria is changing over time. I think there's a huge amount of information just in the DNA of the environment around us, and you know, I don't have any scientific evidence to prove this. I have read a lot of papers that are supporting this particular point, but I think that once people can start sequencing their environments, then it enables a lot more people to sort of contribute things. It'd be really fascinating actually to see just like, you know, if you can sort of aggregate huge amounts of citizen data on sequencing, you can see like epidemics, like how they progress. You can get details on like how people's diets change over the seasons, or you know, versus various trends and stuff. I think there could be a lot of really interesting stuff that can come out from getting more of that out into the public. I don't know if people will be like designing custom bugs anytime soon, like, you know, oh, I want to have oil, I'm going to grow some oil-bearing bacteria, or I want some drugs, I'm going to make some drug-bearing bacteria. I don't know if that's in the cards anytime soon, but it would be nice to have a personal tricorder. I think with sequencing alone, you can get a lot of information about your environment. You know, I mean, of course, you only have one genome, and that doesn't change, hopefully. But your gut bacteria and your skin bacteria are constantly changing, and the environment is constantly changing, and those we're finding have a greater impact on our health and our well-being than we had previously thought. And those could be really interesting pieces of data to have. pretty interested by astrophysics. I think every geek sort of looks to the stars and like says, "Wow, like the curiosity is awesome." And I was just reading about the Huygens probe and all that sort of stuff. There's a lot of really just fascinating stuff that happens in that area, and the amount of just the science that's being done, the quality of the science, and the amazing precision that we're able to measure the wobbles of stars and stuff like that to see if plants are out there or whatever it is, their occlusion from very distant stars. It blows my mind. So I wrote a paper about the Xbox. Actually was an academic paper, which is part of the reason that I got it relatively leniently, because it was recognized by the academic community as a contribution. It wasn't just some random Yahoo doing hacks. Which is unfortunate that it has to be that way. I mean, it should be that people should be able to do science in their own home and not have to write a paper to be approved by the sort of the priesthood or wherever it is. But it is what it is, I suppose. That should change. And then I did when I did the 40 gigabit modulators in silicon, I got a paper about that in some conferences, and I've written some journal articles and stuff at the moment. And the Xbox stuff was incidental, actually. It was an accident that happened in a lab, right? It wasn't really something that I had intended to really do. It just happened because I was curious and I found the result that was cool. So I wanted to make sure that I wasn't just falling into the sort of the pigeonhole of the Xbox guy or the reverse engineer. And so I spent a fair bit of time. I mean, I do on design, but I also like to do design as well. I'd like to be remembered as someone who can do both, right? Not just take things apart, but also put things together. So, the silicon hacking stuff was great. That was a good phase of my life. About every 4 years, I kind of like reinvent myself and do something completely different. And then the Chumby stuff was great because I got to give something to the world, open hardware designs, and I find that very satisfying to kind of share my results and bring it to the world. I don't know what the next thing is. I mean, I have an itch for biology, right? I would love to make a contribution there. I don't know if I can. It's a big hill to climb, and I also like art a lot as well. And so I'd like to do something, not necessarily technical, but maybe just something beautiful. So there's a few things left for me to try and play around with. So, but I don't know what's next yet. The most significant thing I see happening is that Moore's law is ending, and probably will come to an end in about a decade or so. And so what will happen is that these things won't get any smaller or faster, and your computers won't get any faster, you won't get any more RAM, you won't get bigger hard drives, all that sort of stuff. So everything that has driven the internet ecosystem so far, we push crappy software, we wait 2 years and it runs fast. We enter a different era of optimization, where if you want something to be better, you actually take the same code base and the same feature set, and you make it more reliable, you make it run faster, and that's a completely different sort of mentality from the just pure sort of new features and sort of information bloat kind of age. So I think that there'll be a lot more room for individual innovators in that space, because it's a lot easier for a very bright person to take an existing product and really polish it, make it beautiful and heirloom quality and add value, versus like trying to create these whole new new phones. Like one person can't build an iPhone, right? But one person can build a beautiful sort of well optimized app or make a huge contribution to a web browser or something like that. So that'll be a big change. I wouldn't say it's a brick wall. It'll be a little softer than a brick wall. But like every exponential curve, like you go through any growth curve of any population, it's an S curve, right? It eventually has to level out, right? No exponentials are forever, and we are hitting physical limits. Anyone who designs chips will tell you that we've been hitting them for a long time. It's getting much harder to make these changes. I think that people who are in the computers right now, who want to have a viable business in the next 10 years, should be thinking maybe where they want to land, right? We're so busy right now sort of where we want to go, and it's the next one, it's the next one, it's the next one, and then what will happen is someone will reach for that next rung on the ladder, there'll be nothing there, right? And that guy's going to maybe fall off the ladder, right? And you sort of maybe slow down a bit and say, where do we actually want to sort of stop and hold on and really, put some pegs down and hold on and figure what's next. There's a huge biological analogy. Every population is classic sort of fox versus rabbit island stories where the rabbit population explodes and then flattens out and then collapses, and then the fox population does. These kinds of things happen. But I don't see you know, like for example, graphing technology or quantum technology or superconducting technology catching up fast enough to really fill that gap. When those things come about, like there will be another little jump, right? But even so, it's like we're already at atomic scale lithography, right, on a lot of these things. I mean, atoms are sort of, we haven't really found a way to really beat those yet, I think. Humans just want new things because we're humans and we like beautiful new things. There's going to be more emphasis on that end of technology as opposed to just like cramming more features into a little box. When Google started, I loved using it because like it was simple. It's just search, right? I mean, compared to Alta Vista or Yahoo, there's like all this like stuff in Portal, but you know, as every service evolves, it seems inevitable that they kind of clutter up and start to add a lot of features. I think I like my search engine simple, right? I don't use any of the Google Cloud services because I don't really like them. I mean, it's neat that they can sort of customize your life to what they know about you. It's also kind of freaky and it weirds me out. So I think also there's a huge amount of kind of linguistic barrier. I mean, you mentioned Baidu. I kind of, just for shits and giggles, I oftentimes put one search into Google, one search into Baidu, and just look at the just amazingly different results. And a lot of times I can't find it in Google, I may find it in the other search engine. And it's also partially just because of linguistic bias. Like there's this like other half of the internet that no one ever sees inside this country called China with this huge firewall, and it really is like a different world on the inside of there. There are whole services that from, like the firewall not only keeps people on the inside from getting out, it keeps people from the outside getting into certain services, is what you'll discover. There's like a lot of really interesting things that happen in China on the internet that we just can't find out about because we're outside the firewall. The question depends in part if you believe that traveling to the past can actually have an impact on the future that we know now. If I'm just going to go to the past as a tourist, then that's not as interesting because that's history, right? If I can actually make a difference, then I would pick a point in the past. I would think that past time travel may not impact the future we know today, so given that, maybe posit, I would want to go into the future because I'm going to die someday, and I'm really curious where this planet ends up, right? You know, once, like, do we actually get to the point where we manage our population growth and we sort of settle in, and do we ever reach for the stars, and do we ever get to these points? Like, it's sort of the story that I really want to know the ending to. So a lot of times in books I'll like kind of cut to the end and sort of peek at the last couple pages. It'd be kind of something like that. Pick something fairly far out, like maybe even millions of years out, right? You know, once the continents have shifted substantially, and like, you know, I always wonder what happens in these mega cities that are in places that you know will be underwater or will raise up like another 1,000 feet, and then like how do humans deal with like these kinds of things that we've never had to deal with before? You know, I would be really curious to see like how we handle these challenges. All I really wish for is that I can help people in some meaningful way. I don't know what it is, and I think it'll find me when the time comes, and I hope to be ready to do it. Maybe I just wish that my purpose finds me someday and I can fulfill it adequately when it comes.